In this video, I will be going over lesson 8, which is about problems with rational numbers. Our first problem here says that Hans spent 3 days baking 224 cookies. On the second day, he baked twice as many as he did the first day. And on the third day, he baked half as many as he did on the first day. Which equation represents the situation if x is the number of cookies Hans baked in the first day? Okay, so let's think about this. Hans is baking cookies over 3 days, right? So we have his first day of baking, his second day of baking, and then his third day of baking. So the first day of baking, we don't really know how many cookies he baked. All we know is that he baked some amount of cookies on the first day. Since I don't know how many he baked, I'm going to just put an x, right? A variable is something that represents a number that we don't know yet. And I don't know how many cookies Hans baked on the first day. On the second day, though, I know that he baked twice as many. So on the second day, he baked 2 times as many. So for day 2, I'm going to let that be represented by a 2x, right? This x right here is how many he made his first day, except now I know he's baking 2 times as many, which is why I have this 2 here. And then on the third day, it says he baked half as many as he did on the first day. So the third day, he baked 1/2 as many as he did on the first day. So again, first day is x. I don't know how many. The second day is 2x because he baked twice as many. And then this third day is 1/2 x because he baked half as many. And remember that our total always goes on one side of our equal sign by itself, and the total number of cookies he baked was 224. So if I were to add all of these together and set it equal to 224, this equation right here is what would represent how many cookies Hans baked. So looking through our answer choices, I want to pick this one. So x plus 2x plus 1/2 x equals 224. Our next problem says that Leanne bought 2 3/4 pounds of apples for $1.32 per pound, 1.5 pounds of peaches for $1.20 per pound, and some tomatoes from a grocery store. The total cost of this purchase was $9.63, which equation represents this situation if x is the amount of dollars spent on spent on tomatoes. Okay, so I know how many pounds of apples he bought for $1.32 pounds, right? He bought 2 3/4 pounds of apples for $1.32 per pound. So I'm multiplying here because he is buying 2 3/4 pounds of apples, and I know how much he paid, right? So say I were to buy 10 pounds of apples, and each pound of apples was $2. I would do 2 times 10, which would give me 20. So that's why I'm multiplying here. And again, for the second piece of information, we are also multiplying, right? I know he's going to buy 1.5 pounds of peaches for $1.20. So 1.5 pounds of peaches, and he's paying $1.20 for those. Now, I don't know how much money he's spending on tomatoes, right? I don't know how many, meaning how many pounds he's buying, and I also don't know how much they cost, right? I don't know any of that. I just know that he also bought some tomatoes. So for tomatoes, I'm just going to let that be represented by x because I don't know either the pounds or the price that he paid. But I do know that he spent a total of $9.36. So when you go to the grocery store, you're adding together everything that you're buying, right? I'm going to take my apples and I'm going to add that to how much I have to pay for my peaches, and I'm going to add that to how much money I have to spend on my tomatoes. So I'm adding all of these together, and it's going to equal my grand total of $9.63 at my grocery store. So if I'm looking at these answer choices, I want to pick one like letter A here. So this first part represents how much I'm paying for my apples. The second part represents how much I'm paying for my peaches. X is how much I'm paying for those tomatoes, and it's equal to my total of how much I'm spending. All right, for number 3, this third question here, we are taking that equation that we made for the very first one with Hans when he was baking all those cookies. And now we're solving it for X, and we want to also know how many cookies he baked on his second day. So I'm going to copy that equation. And it was X plus 2X plus 1/2 X equals 224. So I need to first solve this and figure out, well, what is X, right? And if I look right here, I see a lot of common variables. I see an X, X, and X, which means I have like terms, which means that I can combine like terms. So if I have an X and 2X, right, that gives me a total of 3 X's, and I'm adding that to 1/2 X. 3 plus 1/2 is just going to be 3.5, right? I'm taking 3 and adding it to 1/2. That's going to give me 3 1/2 X. And this is going to be equal to the total number of cookies that Hans baked. Okay. So since we're solving equations here, I'm going to take this 1/2 and I'm going to rewrite it as 0.5, right? If I have 0.5 as a decimal, that's the same thing as 1/2. I'm going to rewrite this as 3.5 just because it's going to be a little bit easier when we solve this. All right, that 3.5 is being multiplied to X here. So to undo this multiplication, I need to do division. So opposite of multiplying by 3.5 is going to be dividing. Remember, anything you do to one side of your equal sign, you have to also do to the other. So those are going to cancel, and I'm going to be left with just X. And for this next part here, I am going to type this into Desmos, our calculator, just to help us to make sure we get the right number since we do have decimals. So I'm going to do 224, and I'm going to divide that by 3.5. And when I do that, I get 64. Okay, so this is where we have to be careful here. 64 represents X. And if I look up here and I think back to our equation, this X right here represents how many cookies he made on the first day. Remember? So we didn't know how many, we just knew he baked some amount on the first day. Okay, so if I look at the question is asking me how many did he bake. Whoops, sorry. The question's asking me how many did he bake on the second day. And if I think back, this 2X here represented how much he baked on the second day. So I need to take 2 and multiply it by X. And X is this 64 here. So I'm going to take 2 and multiply it to 64. 2 times 64, you can type this into a calculator if you would like. When you do that, you will get 128. So that means that Hans is going to bake 128 cookies on that second day. That is quite a lot of cookies to bake in one day. All right, our next question is asking us, well, how much did Leanne spend on those tomatoes? Remember, we created that equation for this problem with the tomatoes. We want to know how much did they actually spend. All right, well, what I'm going to do is first start by writing my equation. So this was 2 3/4 times 132. We were adding that to 1 1/2 times 120. X, which was my tomatoes, and I'm going to set that all equal to how much I paid. Okay, so the first thing we need to do here is we need to do some multiplication, right? This right here and this second part right here, those are numbers I can just multiply together. There's no variables there, so let's simplify it to make it a little bit easier to look at. All right, so I have 2 3/4, and I'm going to multiply that by 1.32. And I'm going to do the second one right now as well. So I have 1 1/2, and I'm multiplying that to 1.2. All right, so it looks like I'm going to get 3.63 and then 1.8. I'm adding this to 1.8, which is added to X, which is equal to 9.63. Okay, so from here, let's keep adding. I can add these two numbers right here, right? Because those are my like terms. So let's bring back our calculator really quick, add those two together. So 3.63, and I'm adding it to 1.8. And that's going to give me 5.43 plus X is equal to 9.63. From here, I just need to get rid of this 5.4, right? 5.4 is the only thing left next to my x in order for it to be alone. So the opposite of this positive 5.4 is going to be a negative, right? The opposite of a positive number is a negative. So to get rid of it, I need to subtract 5.4. 3, and remember that anything we do to one side, we have to also do to the other. So these are going to go away. And I'm going to be left with x is equal to, all I need to do is do this subtraction right here. So let's bring back our calculator to do our subtraction. So I'm doing 9.63 and I am subtracting that from 5.43 and I get 4.2. Which means that Leanne spent $4.20 on those tomatoes. All right, 2 more questions, guys. Our next question says that Veronica walks dogs in her neighborhood for extra money during the summer. For each dog, she earns $5.25. On Monday, she completes 3 walks, and on Tuesday, she then completes 2 walks. She estimates that in order to save up money for a new purse that costs $86, she needs to complete 12 more walks by the end of the week. Is Veronica's estimate reasonable? Why or why not? Okay, so let's see. She earns $5.25 each time she takes a dog on a walk. And it looks like she did 3 walks on Monday and then she did 2 walks on Tuesday. So between those 2 days, she took a total of 5 dogs on walks. Okay, so she did 5 walks. And she earns $5.25 each time she walks a dog. So if we multiply this by 525, that's going to tell us how much money she already has saved. Okay, so let's multiply it. 5 times 5.25. Oops, not divided by, we're going to multiply it. So it looks like from here, she has saved $26.25. Okay, she needs $86 for her purse that she wants to buy. So if I were to take how much she has to pay for her purse, which is $86, and I subtracted it from this here, this $26.25, which is how much she already has saved, that is going to give me how much more money she needs. So if I take 86 and subtract it from that 26.25, I get almost $60. Whoops. Almost $60. I'm going to round it to about 60. Okay, so she needs to go on 12 more walks. And remember, for each walk that she does, she gets $5.25. So if she does 12 more at $5.25, 12 times $5.25, let's see what that gets us. That gets us $63. And 63 is a little bit more than the 60, right? Which means if she does 12 more walks, she will be able to buy her purse. So yes, her estimate is correct. Let's read through these reasonings and we could see which one is the reason why. So our first one says yes, because 5 is very close to 5.25 and 85 is very close to 86. And if I add all together, these are her walks that she's doing. And if I were to multiply them by 5, I would get 85. So it's a little bit different from how we thought about this, but let's just double check this and see if that makes sense. So if I take all of the walks that she does, that 3 on Monday, 2 on Tuesday, and the 12 she's doing for the rest of the week, and if I take that 17 and I multiply it by this 5 that's out here, I do get 85. So B is correct here. So her estimate was spot on. All right, and last question says that Giovanna makes $11.25 per hour at her part-time job. During 1 week, she also earned $30 in tip money. And her final pay for the week was $159.50. Which answer gives the best estimate for the number of hours that she works? Okay. So Giovanna earns $11.25 per hour. Okay. She also got $30 in tips, right? Tips are money that's just added to your paycheck. Okay. So her final pay for that week was $159.50. We need to kind of work a little bit backwards here and figure out how many hours did she work. Well, if I were to take this $159.50 and subtract the $30 that she earns in tips, that's going to give me how much money she earned per hour for all of the hours that she worked, right? Because the money that you earn in tips is not a part of how much you earn per hour. So when we subtract this, we get $129.50. And I know that she earns $11.25 per hour. So to figure out how many hours she worked, I need to divide this number by 11.25. So I'm dividing all the money she got just for working, and I'm dividing it by how much she gets per hour. That's going to tell me how many hours she worked. So if I do this, I get 11.5. So looking at these answer choices, 13 is going to be closest to 11.5. And the reason why it's not the exact same number is because we're asking for an estimate, which means that we're technically rounding during these questions. So instead of $11.25 per hour, we'd probably round that down to just $11 or maybe even $10 because that's an easier number to work with. So we just wanted a rough estimate. So 13 is that closest to 11.5, which is why that one is correct. All right, that is all that I have for lesson 8. If you have any other questions, please let me know.